Hello everybody and welcome to our first lesson in geometry. Unit 1 is about logic reasoning and our first lesson is about inductive reasoning. The objectives for the day will be to be able to use inductive reasoning by making conjectures and providing counterexamples for false statements. There are two types of reasoning in logic: inductive reasoning and deductive reasoning. Inductive reasoning is the process of drawing conclusions from a limited set of observations. When we make those observations, we look for patterns, and based on that, we make conjectures. Deductive reasoning is the process of forming a logical argument by using facts, definitions, and accepted properties, and putting these together using the laws of logic. And those laws of logic we will be talking about also some more later in this unit. Let's look at two examples. Julie notices that the floor in each of her 8 classrooms at school has square tiling. She concludes that all of the floors in the school have square tiling. Julie makes an observation. In fact, she makes 8 observations. And based on that, she comes to a conclusion. In other words, she makes a conjecture. Making a limited number of observations and based on those, coming up with a conjecture. This is an example of inductive reasoning. Let's look at the second example. An equilateral triangle is a triangle where all sides are congruent. Tom measures the sides of his triangle and they are each 8 inches long. Tom concludes that he has an equilateral triangle. The first sentence, an equilateral triangle is a triangle where all sides are congruent, is a definition. Tom then goes ahead and measures his own triangle, realizes that it has indeed 3 sides that are 8 inches long, and based on that, Tom concludes that he has an equilateral triangle. Using one or more definitions and applying the laws of logic to them, this is what we call deductive reasoning. Now pause the video and using your own words, describe the differences between the two examples above. Write your observations on your note sheet in the margin on the left. This is what your note sheet should look like. And to the left of inductive and deductive reasoning, this is where you should write your observations about the two examples and the two different types of reasoning. A conjecture is an unproven statement which is based on observations. Look at this example. Analyze the pattern and make a conjecture about what shape should come next. Draw this pattern of polygons and your conjecture on your note sheet. A counterexample is a specific case for which the conjecture is actually false. Let's look at this example. After studying the figures below and making observations of the right angles formed, one might make the conjecture that all bisectors of a segment make a right angle with the segment. You see the 3 segments painted in black, and each of them are bisected right in the center by a bisector, and that is actually drawn in blue. And in each case, you see that there's a right angle between the bisector and the original segment. But I can draw a bisector just like this. The red bisector also bisects the black segment in the middle, cuts it in half into 2 equal pieces, but this new bisector does not form a right angle with the segment. It actually forms an acute angle. And we could find more examples like that, also bisectors that form an obtuse angle. But the point is, one example where the conjecture is proven to be wrong is enough, and that's what we call the counterexample. Let's look at the next 3 examples and show that the conjecture is false by finding and writing down a counterexample. Number 3, all triangles are equilateral. Well, there is a scalene triangle, and scalene triangles have no congruent sides. So a scalene triangle is a counterexample for this first conjecture. Our second conjecture states that no quadrilaterals have congruent sides. Well, let's look at a square. A square is a quadrilateral. It has 4 sides, and all 4 sides are congruent. In other words, they have the same length. So this is a counterexample again for the conjecture that no quadrilaterals have congruent sides. Let's look at that last conjecture, similar to the one that Julie made earlier in this lesson. And you guys take a minute, pause the video, and think about a counterexample that will prove the conjecture wrong. The conjecture, if the floor has square tiling, then I must be at school. Please take a second, pause the video, and write your counterexample down. There are all sorts of patterns in math, but also in the real world. So I would like you to take a moment and look around in the room that you're sitting in right now and find patterns. Find patterns and describe those patterns on your note sheet. All right, this concludes today's lesson on inductive reasoning. As a summary to conclude your notes, please compare and contrast. Write the differences and the similarities between the 2 concepts we discussed, the concept of inductive reasoning and deductive reasoning. Please make sure to finish your notes, and I'm looking forward to seeing you in class.